Alexey has joined us. He's come in from Amsterdam and he's done a tour across Asia. I'm not sure how many cities you cover, but it's been quite a bit.
I also don't count.
Yeah, he doesn't count, but we're also heading to Sydney at the end of the week, and then we're up to India as well. But yeah, without further ado, wanted to introduce Alexey, and thank you all for coming tonight. Take care.
Thank you. It's nice to be here in Australia. It's the first time I'm here, and so far I have pretty good impressions. But it depends on you, on the people, on your reception. And my presentation today is about AI. AI, it is such a hot topic that it starts to be even boring. Everyone talks about AI, AI, AI. But don't worry, it's not about using AI models. It's not about creating new AI models. It is about the data behind large language models. What data is used to actually create this model with human knowledge? Let's take a look. There are many datasets that you can get from the internet, or datasets that are already collected by someone else and ready for being used. For example, Common Crawl, it is an open dataset containing monthly crawls of the part of the internet, like hundreds of terabytes every month, HTML pages. There are filtered prepared datasets like ZipFile, OpenWeb, or FineWeb 2. They are typically based on Common Crawl, but people took effort to deduplicate the pages, to filter out inappropriate content, to filter out content with different licenses. And they are like ready-made for pre-training. There is data from social networks like Twitter. No, you cannot download Twitter. If you try to do, Elon Musk will be probably very angry. But there is a data set with like 1% of the data crawled from the internet. There is Wikipedia with human knowledge, perfectly curated. But if you train your model on Wikipedia, it probably will be a very boring language model. Instead, you can train it on Reddit or 4chan. Then your language model will be not boring at all. About the sizes. So Common Crawl contains 2.5 billion web pages every month, half petabyte of uncompressed data, 100 terabytes of compressed responses. And if you extract text from HTML, it will be just about tens of terabytes of compressed text every month. Wikipedia is quite small, just under like 10 gigabytes. FineWeb is pretty massive, but also smaller than Common Crawl. Let's explore these data sets. Let's try to look at them. When I see any data set on the internet, the first thing I do is I load everything into ClickHouse. ClickHouse is my favorite database. Hopefully yours as well. And I want to find any opportunity to test it, any opportunity to challenge it. So I take the largest data set, load it, and find if everything breaks. If everything breaks, I am happy because I can improve ClickHouse. If nothing breaks, I am also happy because ClickHouse works perfectly. And this is the way how I remain happy every day. So many of these data sets are open, and many of them are published on Hugging Face. And Hugging Face provides an API which allows you to list these data sets in a form of Parquet files. If I do this query, which selects from URL table function. This URL table function will query the API directly. The API will return an array of files, and I will flatten, it is named array join in ClickHouse, this array into records. And we will see that fine web is 26,000 of records, 46 terabytes of Parquet files, about 25 billion records, 73 terabytes of uncompressed text, and if we take text and metadata, it will be about 80 terabytes. And here is the list of files and the query that gets this list. Then I can create a table to accommodate this data. To create a table, I use a create table statement, but I don't specify any table structure. The structure will be automatically inferred from Parquet. In this case, I do create table empty as select star from URL with Parquet file. And if I check the table structure, it looks like this. Text, URL, date, language, the number of tokens, pretty easy. I did not even create a primary key. In this case, it is an empty tuple. I don't need any sorting of this data. And now let's load everything into ClickHouse. I did it this way. With the first query, I generated 26,000 insert queries from Hugging Face. And then I run these 26,000 insert queries in parallel with 50 parallel connections. And the first question I had, if Hugging Face will ban me for that, if it will sustain this load. And surprisingly, it did not ban me. But the next question I want to ask you, what do you think, how long did it take to load 81.5 terabytes of data into ClickHouse? 24 hours. Nice hypothesis. By the way, which database do you use in your daily work? Mostly. Postgres. Okay, so it's quite understandable why do you say 24 terabytes. Yeah, that's actually a good assumption about the network cost. Any more hypotheses?
How big is the compute?
What? Sorry?
It depends on how big is the compute.
That's absolutely correct. I load this database into ClickHouse Cloud with 20 machines.
1 second.
That's a very good hypothesis. And if I ask which database do you use, probably the answer is ClickHouse. But it is like ClickHouse version 3000. Any more hypotheses? 1 minute.
No, that's it.
30 seconds. Sorry? 30 minutes. Okay, let's take a look who is the closest to the right answer. It was 72 minutes. 1 hour, 12 minutes. Do we have gifts for our...
Yes.
Yeah, let's give this gift to the guy who said 30 minutes.
What size? I got medium or large.
He's extra.
Ah.
Yeah, just the old.
And I would like to additionally ask to give a gift to the one who said 1 second. Because I really like it.
Is that you?
Yeah. So 33 terabytes. One interesting fact that inside ClickHouse it took only 33 terabytes, while the size of Parquet files in total is 46 terabytes. And it's interesting to ask why, because in ClickHouse we use ZST decompression. In Parquet files they use ZST decompression. In ClickHouse we use column-oriented data format, and Parquet is also column-oriented data format. So it's a question why ClickHouse does it better. And I don't even have the answer. ClickHouse just does it better. And ClickHouse is able to load, like, if you take fine web data set, you can train a model in the quality of something like Llama 2. It's not like the most modern, it's kind of a research data set, but it is suitable for a pretty good, for training a pretty good open model. Now let's take a look inside this data and explore it. Like, from which websites this data is made of. Let's do an aggregation query. Here is a ClickHouse UI, here is my query, and it processes with the speed of 250 gigabytes per second. It is pretty fast. It processes at about 150, 170, almost 2 terabytes of data. And here is the results. Wikipedia, The Guardian, Business Insider, Fox News, Fan Fiction, Telegraph, Daily Telegraph, TripAdvisor, Bloomberg, New York Post, Variety.com. So mostly Wikipedia and news. So I'm quite a bit afraid maybe this data is not really as representative. But maybe it is just tuned for encyclopedic knowledge and news. Maybe it should be a little bit less boring. And fine web is not enough. To make it less boring, we can take Reddit or Twitter. To make it more boring, we can take archive or archive. GitHub is pretty interesting. You can train your language model on archive, but then it will start to speak in a passive voice. Probably this is not what you need. GitHub is pretty interesting for the code. It contains a lot of duplicates, like thousands of forks of Linux kernel. But if you take all of it together, it will be about 300 terabytes of compressed data, pretty massive, way more than Common Crawl, for example. With data from Flickr, images, photos, you can train a multi-model data set. And what is interesting, all of this data set will fit into just a single service in ClickHouse Cloud. Because everything will fit in just a single service in ClickHouse Cloud. ClickHouse Cloud is infinitely scalable. Now let's compare these data sets together. How to compare them? How to compare them by their character, by their style. Let's do the most trivial thing we can even imagine. Let's count words, count tokens. So I created a table, named Blue Sky tokens stats, Wikipedia token stats, Hacker News token stats, and so on. It contains just 2 columns, the token and count. And with this insert query, I just count tokens. So I have text converted to lowercase, extract words with the tokens function, do array join for flattening these arrays, and just insert 1 into the table. And the table has an engine summing merge tree. This engine will automatically sum all of this data in the background. In addition to tokens, we can also calculate n-grams, like bgrams. And thankfully, ClickHouse contains functions for generating these bgrams, 3 grams, n-grams. Here is the function array shingles. It will take an array and create another array of just pairs or triples of consecutive values. Okay, now we have this data, and let's do the comparison. For the comparison, we will calculate the most popular tokens and calculate their frequencies relative to other tokens. And then we will just extract the most contrasting tokens among the top ones. Interesting what the result will be. Let me take a look. Let me run this query. Here it is. And we will compare Blue Sky and Hacker News. On Blue Sky, the top is social, she, him, love, please, hope, today, so much, yeah, and fun. Sounds nice. In Hacker News it is data, Google, system, problem. That's it. There are. I found Blue Skies much more interesting than Hacker News. Now, I did this comparison for almost every dataset and found that also on Reddit, the top tokens are action, level, pretty, content, and yourself. And I'm even afraid to say what is before yourself. It was also interesting to check Wikipedia. On Wikipedia, the most interesting is unpopular tokens. And the most unpopular token is you. You are very unpopular on Wikipedia. Me as well. I don't have a page on Wikipedia. Now another experiment. We have a fine web dataset, and you remember it contains many other websites, many other datasets, including Twitter, Reddit, Hacker News, and even ClickHouse website, and even many, many more websites. What if we will calculate something that I name a style fingerprint? This fingerprint will be an array of numbers of size 1024. And I calculate it like as follows. First, let's take every token. Let's calculate a hash of this token, city hash 64. Let's take a remainder of division by the vector size. So it will be a position in 1024 dimensional vector. And in that position, I will just increment the number by 1 and do it for every existing tokens. Here is my query. To generate this array, I use an aggregate function named sum for each, which is pretty nice. It will take arrays and sum them like vertically. Now let's take a look at the results. Let's take a look which websites are similar to clickhouse.com. Let me copy paste this query. It is pretty fast. And here is clickhouse.com itself, imply, red panda, planet scale, source graph, confluent, dgraph, airbyte. So it works. I'm actually surprised because it was such a simple query, such a simple idea for style fingerprints, but it allows me to find similar websites. Also, I have a question why fan fiction is similar to ClickHouse, but I don't know. What about trends on the internet? Let's take a look at the Reddit and calculate the trend of love. Here is love on Reddit. It is still strong. What about ClickHouse? ClickHouse is even better. What about Hadoop? Hadoop is goes down. Blockchain. Blockchain was popular and it is still popular, but quite volatile as expected. Now about multi-model datasets like Flickr. Flickr hosts billions of photos. It is not as popular as it was like 10 years ago. And most of these photos have attributed with a pretty permissive license that allows their usage in datasets. And the question is, what would I do if I presented with a dataset of billions of photos? Do you have any?
Content moderation.
Content moderation. Interesting idea. I don't have to do moderation, and I found it is not as exciting as just take everything. What would you do with 1 billion photos? And these photos contain a lot of metadata.
Size.
Sorry?
Size.
Analyze sizes of photos. Yeah, pretty interesting.
Location?
Location. That's exactly what I did. Who said location?
You said location. Oh, yeah.
I generated a map of the photos. So here it is. This is website, and this is the density of photos. But more interesting, I can press this button, and for each tile, it will select the best photo of this location on Flickr. And this service does like 1,000 of queries to ClickHouse, aggregation queries that just select the top photo for each location. And interesting, what will it show for Melbourne? So this website is public. It is not hosted in Australia. It is actually hosted on Europe. But anyway, I think we can use it. And it contains many datasets. And the default dataset is not about photos. It is about airplanes and their movements. And here is Australia, definitely. And so let's switch to photos. Here is the density. If I will zoom in, it should show Melbourne. But interesting, what are the photos in like Tasmania and other locations? How does Melbourne and Sydney compare? And there should be pretty interesting. Moreover, I can use this selection tool, and it will give characteristics of these photos, like real-time report on the tags like Tasmania. I can press on a tag and filter, and everything happens in real time. And what is the best photo of Tasmania? Does it look familiar to you? Have you been in Tasmania? Me, I did not. Now let's take a look at Melbourne. I will take just a little bit of, it should be quick and interesting. What do you think is the most interesting place in Melbourne? Kangaroo? I was like on a walk yesterday and I didn't find any kangaroo. Which square? Ah, interesting, yeah. I did not find any kangaroo, I did not find any koalas. So I'm a little bit disappointed of Melbourne. The best photos of Melbourne.
Oh, that's fine.
Okay. So takeaways. ClickHouse makes everything easy. Whatever dataset you have, it could be a large, enormous dataset, but when you load it in ClickHouse, it becomes really fun, it becomes really interesting to use it to manipulate this data. And supposedly, you can put all the internet into ClickHouse, and then the internet will work faster. Thank you.